Hello, I have another piece of equipment by Mackie for repair here. This time it is PPM 808S, a powered mixer, and I bought it quite cheap as non-working, but when I started checking it seems to be mostly working with a few minor problems. This XLR input on channel 7 is not working, and TRS inputs seem to be okay. And also, let me turn it on. This input level set LED on channel 2 is always on. Something is wrong there. So let's take this thing apart, have a look inside and see what can we do about these problems. I removed 6 bolts here on the front panel. So now we should be able to remove it, like so. Oh, look at that! Something went really wrong here, and this is around the faulty XLR connector. So this mixing board can be easily disconnected here, and this ground wire as well. And we have a power amplifier and power supply there on the back. So let's disconnect this thing and have a closer look at it. Here is the mixing board. Let's have a closer look. It seems like this big board is purely analog, and the digital effect processor is on this separate board, and all the components are on the other side of the board, and some component must have burnt here, so we need to remove this board from the front panel. And to do that we need to pull all the knobs, remove all these screws all over the front panel, remove all the nuts from TRS connectors here and here, and remove all these screws around XLR connectors as well. Here is the component side of the board, and check out this pile of knobs, nuts and bolts that had to be removed. So here is our problem, and it seems like one of the op-amps is burnt and probably destroyed a few more components around it. And it looks like at least these 4 connectors need to be desoldered to reach the affected area of the board. Let's see if we can zoom in and have a better look at this. It looks quite ugly there. I managed to desolder the connectors, and it was quite easy to desolder the XLR connectors using my paste desoldering iron. I recently upgraded to this model, which is SX90, and I love it. But the TRS connectors have very wide pins, and I don't have a tip for this guy with such a big hole. So I had to go back to this manual pump, and it was not too bad. So now we should be able to have a better look at the damaged area of the board. Here is the damage, and now it seems to me that this capacitor caught fire and destroyed everything around it. The board sits vertically in the unit, and this way is up. So as we can see, the flames extended all the way up to here. The board is burnt very badly right here, probably all the way through, and the case of the op-amp is cracked right here. So I downloaded the schematics from the manufacturer's website Thank you very much. I wish every manufacturer provides schematics. And I think I understand what components we are looking at here. This op-amp is U77, so let's have a look. This is channel 7, and here it is, U77A, one part of this op-amp. Then in channel 8 there is another part, U77B. And here is another part, U77C. This part has power pins only. And there are two capacitors around this op-amp and all other op-amps. One capacitor is on the positive 16 volt rail and another one is on the negative rail. And this one, C566, on the negative 16 volt rail, is right here, C566. So I believe this one must be C565, this capacitor on the positive 16 volt rail. Also, I can read this designator here, C554, this capacitor, and this resistor must be R775, I think. And here they are, R775, C554, connected right to this op-amp. And there is another resistor here connected to the same point, R776, 10K, and it must be this resistor. So I understand, I believe, what these components are. I'm not entirely sure what these two components are. Maybe it will become clear after some cleaning. So let's start cleaning and see what happens. Here is the result of cleaning. We have a hole in the board. This is the picture before for reference. I desoldered the op-amp and this electrolytic capacitor and started cleaning, and these four components fell right off when I just touched them. This capacitor, which seems to be the culprit, this resistor, this capacitor, and this resistor. And by the way, these three components still measure fine with the right values, but not this capacitor. It is still one piece, but I could not measure anything across it. And this electrolytic cap seems to have survived. There's a stain on it from the flames, but it measures fine. And these two components, here they are, they look okay, and this resistor looks okay. And I had to remove all charred and fragile fiberglass. It was conductive and did not support anything anyway, so I had to scrape it away and cleaned everything thoroughly with alcohol. And now we need to rebuild this thing. So we need a new op-amp, 4 components around it, and restore a few traces. And we have schematic, we know what the components are and how to connect them together, so it should not be a big problem. It's not going to look pretty, but it should work. Let's try. I don't happen to have these op-amps, so I'm looking for them here on Mouser. These are 4560 op-amps, quite popular and nothing special. They exist in all sorts of packages. We are interested in SMD. Let's apply that filter. And still too many options. I looked at the datasheets for all these packages, and in particular for physical dimensions, and carefully measured the op-amps on the board. And I believe we need this package, DMP8. Let's apply that, only 4 results remaining, and all of them are NJR and all look identical. Yeah, so let's select this one. 69 cents for one and $6.05 for 10. I will order 10, why not? It's cheap enough and might be handy for some other projects, and we never know, we might need more than one for this project as well. Plenty of them available, should take just a few days to get them. Here we have 10 new op-amps, resistors and capacitors, and a new electrolytic cap, because this one looks a little bit cooked. I'm going to replace it just in case. Let's start rebuilding. I'm trying to test this mixing board here by injecting a signal from my function generator. Here is my Agilent function generator producing 50 millivolts peak to peak, 1 kilohertz, and I'm probing on the mix left channel output, and I'm getting nothing at all from channel 7. The gain is set to the middle, and I tried the same on channel 6, injected here using this XLR connector, and I'm getting nice output, no problem at all. And I also tried channel 8, injected the same way by hooking up to through-hole resistors connected directly to the XLR input, and channel 8 is working as well, but nothing at all from channel 7. So I started probing around, measured voltages and such. First of all, power rails, they look fine, about 14.7, 14.8 volts, which is a bit lower than 16, but not a problem at all. This does not have to be precise. And so I started probing voltages all over the place on op-amps and transistors and such, and I think I see a problem. Let me show you on the schematic. This is channel 7 schematic again. As I said, I started checking DC offsets here, and in particular this point. We have a divider here between positive and negative rail, shifted towards negative. We have 27K from positive and 3K from negative. So I see about negative 11.8 at this point. And we should see, of course, the same voltage on all inputs here and here. And that's what I see on this one. The voltages are the same, and output is sitting at about 1.6 volts. And I see exactly the same in channel 8 on both op-amps, but not on this second one in channel 7. I see about negative 14.8 here on pin 6, which is essentially the negative rail. And the output is sitting at about 0.4 volts. So I believe this op-amp is dead. So let's try replacing this op-amp and see if this fixes the problem. The op-amp is replaced, and there you go, we have nice output from the mixer. Injecting 50 millivolts peak to peak into channel 7. The gain here is set to the middle. There is an indent here, And the master volume is also set to the middle, and we see the first LED in the level indicator. And we have about 430 millivolts peak to peak on the output. So channel 7 is alive, and now we need to solder the connectors back and work on this peak detector in channel 2. Here is the peak detector in channel 2. It is based on LM339, very popular quad comparator. And this negative input is monitoring the signal, and it is sitting at 0 volts. And this positive input is connected to this voltage divider, which sets the threshold for comparison. And I measure about 1.13 volts here. So the positive input is higher than negative, so the output should hit the positive rail. And that's what I see in all other channels, but not here. This guy has about negative 12 volts on the output, which is wrong, obviously. So I think this comparator is dead. Guess what? This is one of those embarrassing moments. I'm sure everyone who tried fixing something knows what I'm talking about. You're almost sure you know what the problem is. You replace a part which you think is bad, and nothing changes. So we have exactly the same problem. I believe this LM339 most probably is okay, and the problem is with something else. Back to the schematic. So what can possibly go wrong here? This peak detector is such a simple circuit. And if we assume these two comparators are fine, then I think this output can be affected by two components only, this resistor and this capacitor. And with 0 volts on this negative input and about 1 volt on this positive input, we should see effectively a positive rail on the output. And this thing relies on external pull-up for that, which is this resistor. So maybe it's not pulling up as it should. Or maybe this capacitor is pulling down somehow. I measure about minus 12.8 volts at this point, and this negative rail is about minus 14.8. So about 2 volts drop across the capacitor. At least it's not shorted. And I think I checked both resistor and capacitor in circuit, and on the first glance they look fine. So I'm not sure what's going on. Maybe I should just replace them because it's easy and to see what happens. I started with the capacitor, I replaced it, and the problem is gone. So I connected my signal generator to channel 2 for testing. Let's see, we should reach this threshold at some point. There you go, at this point we reach the threshold, and this is supposed to be the optimal level to use the available dynamic range better. We want the signal to be as high as possible above the noise floor, but not too high, so there is still some room before clipping. So this works as expected, and here is the capacitor I replaced. This is a tiny surface mount capacitor, and surprisingly it measures just fine. Let's try. There you go. Around 100 nanofarad, no problem at all. So I'm not sure what's going on here. Maybe it starts leaking at higher voltages or something like that. Or maybe there was some contamination on the board that I cleaned effectively during soldering. I'm not sure. And now let's have a look at the power amplifier and power supply, just because we can. We don't want to miss the opportunity, do we? It seems to me that this metal plate is just sitting here behind the mixing board as a shield, attached with the 4 bolts, and behind it we will see the power amplifier. Let's go. Look at that, we have a massive toroidal transformer here, so this thing has a linear mode power supply. So we see a mains input here, then power supply must be here in the middle of this board, some bridge rectifiers here and here, plus and minus 15 volt regulators, and then almost identical sections on the left and on the right. It seems like each amplifier has 3 transistors in parallel on the high side and on the low side. Very nice. So this is the output from this channel, output from this channel, going into this output board. And there is no fan here, just some ventilation holes there on the bottom, on the sides, and here on the top as well. And all this thing is sitting on a massive heat sink on the back. Here is the back of the unit with this massive heatsink, ventilation holes here, mains input, power switch, and output connectors here, nothing else on the back. 2 600-watt channels. Alright, the mixer is back together and works great. I hope you enjoyed this little adventure. If you did, give it a thumbs up, subscribe and share. Thank you very much. Bye.